Lesson 6.1 is over solving absolute value equations. Now, this should mostly be review, okay? You have done absolute value equations in middle school, and then you also did it in Algebra 1 as well. So you should be a little bit familiar with this, okay? Does anyone know what the absolute value symbol looks like? Right? It's the lines. It's the lines like this, and then there's stuff written inside. And what does absolute value mean?
Positive.
Everything's always positive, right? Okay, so if I take the absolute value of negative 8, the absolute value of negative 8 is 8, right? But if I take the absolute value of 8, is the answer negative 8? No, it's still 8. So absolute value is actually the distance from 0. So if you were to think of a visual to help you with absolute value, if you actually go old school and think of a number line and you have 0 in the middle, if I was finding the absolute value of negative 8, well, negative 8 is 1, 2, 3, 4, 5, 6, 7, 8 steps from 0, the same as positive 8. It's also 8 steps from 0. And so that's where absolute value is always positive, because absolute value is actually a distance and we don't have negative distance, okay? So when we're solving absolute value equations, we want to keep that in mind and just know, okay, that's what this all means, is that whether it's positive or negative, it's positive. It's the distance from 0. So I do have some steps for us to solve absolute value equations. The first step is to isolate the absolute value expression. We are isolating the absolute value expression. What that means is we are getting anything around the outside of the absolute value bars to the other side of the equation, okay? And then we're going to create two cases. Okay, we will set the inside, or the absolute value, equal to both the positive and the negative value of the number on the opposite side of the equal sign. Okay, so we set up two different cases, two different equations, one where it's equal to a positive value, the other one where it's equal to a negative value, because with absolute value, it could be positive, it could be negative. We don't really know because it's just distance, okay? Then we solve both equations, and we check for extraneous solutions. Okay, we check for extraneous solutions. Does anyone remember what an extraneous solution is? What it means? Right, so you get a solution that's correct, and then you plug it back into the equation and it doesn't work. So solutions that cannot work when plugged back in to the original equation. Okay, so that also begs the question, you have to plug it into the original equation. You don't plug it into one of the two cases that you made. You plug it into the original. Now, there are only certain instances where we have to check for extraneous solutions, kind of like the last time we did it. So these first 4 questions, we do not need to check for extraneous. When we get to the next page, we'll talk about what a question looks like when you have to check for extraneous solutions, okay? So we're going to start off pretty easy and then kind of work our way up to the more challenging ones, all right? So solve the following absolute value equations. So if we look at number 1, we have x minus 5 equals negative 7. Okay, so the first thing we need to do is we need to isolate the absolute value. We see the absolute value bars. Is there anything on the outside that we need to move? No, this one doesn't have anything we need to isolate. So now we can move to step 2, which is to create two cases. We set the absolute value bars equal to the positive and negative value of this number opposite the equal sign. So case one is going to be, actually, no. When we split, we don't need absolute value bars anymore. So we drop the absolute value bars because we're splitting. Okay, so we have x minus 5 equals 7. And then we also have x minus 5 equals negative 7. Okay, we create two cases, and we set the inside equal to both the positive and negative value of the number opposite the equal sign. From here, we solve both equations, okay? So you probably don't even have to show any work here, but we add 5, so we get 12, and then we add 5 again. You should not get the same answer twice because of that negative. So we get x equals 12 and x equals negative 2, okay? Like I said, we do not need to check for extraneous solutions on these problems, and I'll explain what extraneous solution problems look like when we get there. So this is it. We're done. Absolute value is pretty much always going to have two answers when you do it before you check things. So you have two options here. Option one, which I normally do, is you just leave them separately, highlight, circle them, whatever. Okay. Since there are two answers, we can also write this as a solution set. I'm not super particular with you doing it, but I want to show you what it looks like in case you ever see something like it. So we've done this before with quadratics, but you write it as x equals, and you do these little squigglies, and then you just list the two numbers. I usually do them from least to greatest, like that. So that would be a solution set where you're just writing it one time. But once again, I'm not super particular on how you write your answers. I just need to see both answers. Okay? Questions on that one? Okay. Number 2. Do I have anything around the absolute value bars? Yes. What do I have? A 5. Okay. What is this 5 doing to the absolute value bars? It's multiplying, so how do I get rid of it or move it? I divide. Good. So I'm going to divide by 5 and divide by 5. That cancels. I have absolute value 5x minus 10 equals 9. This is now my new original. Okay? That is my new original. So now I'm going to split from here. I'm going to write one positive and one negative, okay? I want you guys to take a few minutes, do that, and solve for your answers. So we got 19 over 5 and 1 over 5. Fractions are allowed. They are okay. If it's an improper fraction, I do not need you to change it to a mixed number. No, if you did, that's fine. I'll check it. But you do not need to. You can just leave it like that. Now, if the fraction needs to be simplified, though, would we need to do that? Yes, you would definitely lose points if you did not leave it in simplest form. Okay? All right, so what I want you guys to do, I want you to try just number 3 on your own, okay? Just number 3. Don't do number 4 yet. So we got 5 and negative 11 over 3. And so once again, you can just leave them separate like that, or if you wanted to write them as a solution set, or if you saw it written like that, that just means that the answer is there's 2 answers, okay? So do we have any questions? Okay. Number 4 is a little bit different. Why is it no solution? Right, I have absolute value of 4x plus 11 equals negative 5. Oh, it's raining. There's nothing, sorry, I distracted y'all. There's nothing around the absolute value, is there? There's not anything in front of it. Listen, come back. I know, it's raining. I'm sorry, I did that.
Yeah, it's weird, though.
It
looks white on the ground.
Yeah, it does.
Yeah.
When I take the absolute value of something, it's always going to be positive. And since there's nothing around this absolute value that needs to be moved, this is just the absolute value of something equals a negative number, which does not make sense, okay? An absolute value of anything, I just put an X, can never equal a negative number, okay? Now, with that being said, if there are things around the absolute value that need to be moved, like there was in number 2 with that 5, if there are things that need to be moved and after those things are moved and the absolute value is isolated, it's positive, then you can continue your problem. But if the absolute value is isolated and it equals a negative number, our answer is no solution. Solution. Okay? So if you have absolute value bars equal negative number, no solution. Okay, now we're going to talk about what a problem looks like when we have to check for extraneous solutions. So sometimes we have to check for extraneous solutions, which once again happens when we get an answer correctly, but then when we plug it back into the original equation, it does not work. Okay? You have to check, or you must, you must check your answers if there's an X outside of the absolute value bars, okay? If there's only X values inside the absolute value bars, you're good. You don't need to check for extraneous solutions. But if you have an X in the absolute value bars and then you have another X wandering around somewhere, you have to check, okay? So you'll notice in number 5, I have an X in the absolute value bars with 2X plus 12, but on the other side, I have equals 4X. So that's what tells me that I need to check this problem, okay? So you need to be aware of that and notice that. Other than that, everything else kind of stays the same. We isolate the absolute value bars, which I've already done. There's nothing around it, right? There's nothing being multiplied, added, or subtracted. And then once I'm isolated, I split into 2 cases. I have 2X plus 12 equals 4X. And I have 2X plus 12 equals negative 4X. I solve. So in this case, I would subtract 2X. Bless you. Okay, solving like normal. But once again, I need to check these answers because I had an X outside the absolute value, okay? If you, and some of you learned this the last time we did extraneous solutions, if you do not show the work of checking somehow, some way, just show me that you are checking your work on a question that needs to be checked, then you will lose points. I need to see the work, okay? So I'm going to check both of these. Now, when we're checking, it's not exactly the same as it was when we did extraneous solutions last time. All that we need to know is that when we plug this answer back in, will our absolute value bar equal a positive value? Because absolute value has to be positive. As long as it's positive, it's a viable answer. So what this looks like for me, I kind of do lazy checking. I don't plug in anything in the absolute value bars. I just plug in here. So I literally just do blank absolute value bars equals 4 times 6, like that. Okay, 4 times 6 is 24. 24 is a positive number, so we are good. X equals 6 is a viable solution. Okay, we're just looking to see if it's positive or negative. We don't need to see if the left is equal to the right or anything like that. And I mean, it will be, but what we're checking for is positiveness. So I'll do the same thing here. I'm going to check. I'm going to have absolute value bars equal 4 times negative 2. 4 times negative 2 is negative 8. So is this one a viable answer? No, this is a negative number, so this is not a viable answer. So my only solution is 6. Negative 2 is not a solution. It's an extraneous solution. That's why normally when I'm solving and I know I'm going to have to check for extraneous solutions, I don't box my answers until after I've checked. And so you'll notice I left 6 and negative 2 there. I solved, or I checked 6. 6 was good, so I boxed it. I checked negative 2. Negative 2 was not good, so I crossed it out. So that's kind of my process for doing that, okay? I want you guys to try number 6 on your own. Give that a go. It's pretty similar. Now, with number 6, it's already negative, but because there's an X there, we can't completely rule it out, because if I plugged in like a negative 7, then that would give me negative 3 times negative 7, which is positive 21. So we can't rule it out like we could with number 4. So with this one, we're just going to do split to 2 cases. The only difference is our first case is a negative and our second case is a positive versus the reverse. Okay, so did I have to check my answers for this one? Yes, I did. Did you guys get negative 1 and 5? Yeah, and negative 1 worked, right? Because negative 3 times negative 1 is a positive 3. But 5 did not work because negative 3 times 5 is negative 15. Okay? Does that make sense? Yes, no, maybe so? Okay. Let's look at number 7. Number 7's a little bit different. Okay, so with number 7, what is the first thing I need to do? Read the problem. What's the first thing? Subtract 7. There is a 7 outside the absolute value bars. I need to move it to the other side. So I have absolute value of 3 minus 5x equals negative 7x minus 7. Okay? Absolute value is now isolated, so we split into 2 cases. The first case, nothing changes. The second case goes negative. And so what this looks like algebraically is it looks like negative parentheses, negative 7x minus 7, like that. Realistically, in Algebra 2, we should be able to immediately go, okay, that means the signs are going to change. 7x plus 7. Yeah? So we should be able to make that jump without showing the work. If you want to show the work, totally fine. I'm not going to judge you. But if you want to just jump straight to that, you can. Now we solve both equations. Okay, this one is a little bit more of an in-depth solve just because of the fact that we have variables and like we have a binomial on both sides. But we're going to solve both sides. So I'm going to add my 5. Do I need to check my solutions here? Why do I need to check my solutions? There's an X outside the absolute value bars. Good. So I need to check both sides. Remember, we are just checking to see if what's on the other side of the equal sign is positive. Now, we are checking the original equation, but we check the version of the original equation that has the isolated absolute value. Okay, so this guy is the one we check, not this one. Okay. Yeah, it's possible, for sure.
They both worked here, right?
I don't know.
No,
They didn't?
-1 there doesn't work.
Why?
Because it's 7 over, -7 over, sorry, 7 over 3 minus 7 is negative. Yeah, 7 over 3 minus 7 is negative. Alright.
Yeah, -5 works. It's a positive number, so we're good.
Oh, wait, you don't use the original.
Right, we use the one that's isolated. Mm-hmm. So I have absolute value bars equals. It's okay, I'll explain it, hang on. Okay, so I have a fraction here, which is no fun, but I have -7 times -1/3, which is positive 7/3. Minus 7. Well, 7/3 is like, what, like 2 1/3? Yeah, it's like 2 1/3, so it's definitely going to be a negative number. Once again, I don't really care what the negative number is. I just know that it's negative, so that's not going to work. Okay, before we finish up, I want you to try number 8. Check your answers, do both sides, all that good stuff. Okay, did you guys get -4 and 6 over 7? This was made before 6 over 7 was a thing. Just saying. Which one worked?
6 over
The 6 over 7. The -4 did not work. Okay, so once again, the biggest thing is isolate the absolute value, make 2 cases, solve. If there's an X outside the absolute value bar, then you need to check for extraneous solutions. When you check for extraneous solutions, you need some sort of way to show me which one worked and which one didn't. First of all, you need to show me checking your work, at least the plug-in, okay? Say, yep, good, positive, no, bad, negative. And then, like, box the correct answer, X out the extraneous, something to show me this one's good, this one's not good. These are both good, these are both bad. If they're both bad, what's my answer? No solution. Okay, cool. Questions, comments, concerns? Okay, great.